Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives, right? And here in this session we are going to discuss this problem in which we are given a function f whose domain is 0 to infinity, and here this is an open interval, so the function f is from 0 to infinity to the set of real numbers r, right? And this function is given to be differentiable function, and further we are given that f prime of x square is given as 2 minus x cube for all values of x greater than 0, and f of 1 is given as 0, and we have to find the value of f of 4. So now this is a very easy problem, and here we are given the value of the function at this point, that is x is equal to 1, that is f of 1 is equal to 0, and we have to find the value of the function at this point, that is x is equal to 4, right? So we are given that the derivative that is f prime of x square is equal to 2 minus x cube. So we'll start with this expression, right? So our aim is to first find out the form of the function, that is f of x, right? So we'll find the function f of x, and then we can easily determine the value of f of 4. So we'll start with this expression, that is f prime of x square is equal to 2 minus x cube, right? Now see here, the input is x square, right? And if we closely observe this equation or expression, then we can see that this is a functional equation in which the derivative of f is involved, right? So let us replace this x square by some other variable, say t, right? So we'll replace x square by t, or in other words we can say that x can be replaced by square root of t, and here this t is greater than 0, because here we are given x greater than 0, right? So this equation now takes the form in terms of t, so we can now write f prime of t, and here we have 2 minus x cube. Now x is equal to square root of t, so here we can write square root of t raised to 3. So now we can write 2 minus t raised to 3 over 2, right? So now we have f prime of t is equal to 2 minus t raised to 3 by 2, and again replacing this t by x, because this is a dummy variable. So we can now write f prime of x is equal to 2 minus x raised to 3 by 2, right? So now we have here d by dx of f of x, and now this is a differential equation, and we can easily find out the function f of x by integrating both sides with respect to x. So integrating both sides with respect to x, we have this expression, that is d by dx of f of x, and we are integrating with respect to x, and here we have 2 minus x raised to 3 by 2, and here we have dx, and c is the constant of integration. So now here we have f of x, and here we have simply integral 2 dx, then we have integral x raised to 3 by 2 dx, and c, and this is f of x. The integral 2 dx is simply 2x, and here we can use this result, that is x raised to n dx is x raised to n plus 1 over n plus 1. So here we have x raised to 3 by 2 plus 1, here we have 3 by 2 plus 1, and c is the constant of integration. So now we have f of x is equal to 2x minus this is 3 by 2 plus 1, that is x raised to 5 over 2, and in the denominator we have 5 over 2, so we can now write 2 over 5, and here we have c as the constant of integration, right? So now to get the value of f of x, we have to find out the value of this constant of integration c by using this condition, that is f of 1 is equal to 0. So when x is 1, then f of 1 is 0. So substituting these values in this expression, we have f of 1, then we have 2 times 1 minus 2 over 5, and here we have 1 raised to 5 over 2 plus c. Now f of 1 is equal to 0, so this is 2, and we have minus 2 over 5, and 1 raised to 5 over 2 is simply 1, and here we have c. So solving this equation for c, we have 0, then we have 5 times 2 is 10, 10 minus 2 is 8, so we have 8 over 5 plus c, and from here we get c is equal to minus 8 over 5, right? So now taking this value of c equal to minus 8 over 5 to this expression, we have now f of x is equal to 2x minus 2 over 5 x raised to 5 over 2 and minus 8 over 5. So this is the required function f of x. Now we can easily find out the value of f of 4 by substituting x is equal to 4 in this expression. So we have f of 4 is equal to 2 times 4, then we have minus 2 over 5, and here we have 4 raised to 5 over 2, and then we have minus 8 over 5, right? So this is 2 times 4 is 8, and here we have 2 over 5. Now 4 raised to 5 over 2 can be written as 2 square, and here we have 5 over 2. Now 2 and 2 get cancelled, so we are left with 2 raised to 5, that is equal to 32. So now here we have multiplied, that is minus 2 over 5 times 32, then we have minus 8 over 5. Now simplifying it, so we have 8 minus 64 over 5 minus 8 over 5. So now f of 4 is equal to, here we can take the LCM, that is we have 5, and then we have here 40 minus 64 minus 8. So this is 40 minus 64 minus 64 minus 8 is minus 72, and here we have 5, so this is minus 32 over 5, right? So the value of f of 4 is equal to minus 32 over 5, right? So viewers, this is how by making use of these concepts we can easily find out the value of f of 4 using f of 1 is equal to 0.